Okay, boys and girls, welcome to Lesson 2. Our objective today is to add and subtract polynomials. This is part 2 of Lesson 2. So, in this video, we're going to talk about adding and subtracting like terms, or polynomials. So, like terms have the same exponent and same base. So like x to the fourth, x to the fourth, y to the, these are what we would consider like terms. So if I had 3x squared comma negative 12x squared, those are like terms, okay? So you can only add or subtract terms if they are like. Polynomials are very discriminatory. To add or subtract polynomials, you want to add or subtract coefficients. Leave exponents alone. And after adding and subtracting polynomials, you want to write in standard form. Highest exponent to lowest exponent. Okay, so let's do a couple examples. So remember, terms are like if they have the same variable and the same exponent. So 4x and 4x are like because they have the same variable, the same exponent is 1, so that would be 11x. Constants are like. So negative 3 and 8 are considered like terms, and that's going to give us plus 5. Okay, this is another example, still pretty simple, but this time we're subtracting. So I have to do 3x and 2x are like terms. So 3x minus 2x is x, or 1x if you will. And then negative 4 minus 6. So this is negative 4 minus 6, which actually we end up adding and keeping the sign, so that's negative 10. All right, now we get to something with just a little bit more meat. And while we're doing this, let me classify this. This would be considered a linear binomial because it's got two terms. That's why it's a binomial. It's linear because its highest exponent is 1. So this would also be a linear binomial. And for this one, 4x squared is the same as 2x squared. They have the same variable and the same exponent. So we're going to add x coefficients that get 6x squared. And then negative 8x and positive 12x. I'm always changing that. I think I'm changing it to the marker, but I'm not. Okay, so negative 8x and positive 12x. Notice I call that negative 8 because the leading term follows. So negative 8 plus 12 is 4. And then the last, the constants are like terms. So negative 3 and minus 5 is 2. And this is a quadratic trinomial. It's quadratic because its highest exponent is 2. And it's a trinomial because it's 3 terms. Okay? And for this one we kind of trick you up here. That's 5x squared. But what is its like term? Its like term is negative 9x squared. So I'm going to combine those two together and get negative 4x squared. Now, when I go to combine 1, I don't have a constant in this second one. So there's nothing I can do with that but bring it down. I have 6x, but there was no x's in that first one, so all I can do is bring it down. So remember I told you we have to put it in standard form. In standard form, we're going to start with the highest exponent, which is 4x squared, and then the second highest exponent was 6x, and then minus 1. Okay, for x squared, again, I was trying to trick you up. x squared. So that is 5x squared. And no, oops, I'm sorry, we're subtracting. So that would be negative 4x squared when I distribute that. So x squared minus 4x squared would be negative 3x squared. Because if there's nothing in front of it, it's understood to be 1. So negative 3x squared, and then we have no other constant, so that's minus 8, and then minus 7x. And again, because I have to distribute that negative. So again, I have to put it in descending order, 3x squared minus 7x minus 8. This is a trinomial quadratic. Okay, and last one. Remember, we can only combine them if they're like terms. So we have 5x cubed. 5x cubed does not have any like terms, so 5x cubed stays by itself. Then we have negative x, and it does have a like term. It's just not in the right place. It does have a negative x, so that's going to be negative 4 minus 4x is negative 5x. There's no other x squared in the expression, so that just comes down. And there's no other constant, so it just comes down. Now, let's put it in standard form. This would be 5x cubed plus 2x squared minus 5x plus 7. And then this is a cubic polynomial. Because remember, I told you after you got to 4, we just stopped naming them. I actually got to 5. So 1, 2, 3, 4. So actually, yeah, so that's a cubic polynomial. After we get to 3 is the last one that we name, mono, bi, and tri. And then after that, we don't name them anymore. Just call them a polynomial. But you can go up to the 5th power and they still have a name. All right, that's it. For this activity, again, you're going to double click. Just ignore all the stuff at the bottom. You're going to double click on here and you're going to move the expressions, match the expressions to the problems, and then you're going to tell me what type of degree, what type of polynomial is by its degree and its terms. So like the one that I did was a quadratic trinomial. All right.